to solve the differential equation and get the solution for that. So here we have equation that is e raised to x into x plus 1 dx plus y e raised to y minus x e raised to x whole dy equal to 0. Now the question is how to get the solution for this differential equation. So by looking at the form, you may say that we can apply the exact differential equation solution method, because in that equation is given in form of m dx plus n dy equals to 0. So for that, what we have to do is we have to differentiate that m with respect to y partially and get the value of dou m by dou y, then differentiate n with respect to x, get the value of dou n by dou x, and if both the values are same, then we say that yes, it is exact. So guys, if you'll check that, then you'll find that it is not exact. So then how to get the solution? So guys, here if we simplify this equation, then we can convert that equation into such a form that it can be reduced to linear differential equation form. So what is the linear differential equation form? So here I'll show you. The equation given in the form dy by dx plus py equal to q is called as linear differential equation. So my objective will be to convert that equation into this form and then get the solution. So for that, what we'll do is I'll shift first this term on the right hand side. So we will get therefore e raised to x plus 1 dx equal to negative y e raised to y minus x e raised to x dy. Now I can take this dy on the left hand side. So we will get e raised to x plus 1 dx upon dy equal to minus y e raised to y plus x e raised to x. Now guys, I'll take this second term on the left hand side purposely. Now I'll tell you the reason. So first I'll shift and I'll tell you the reason. So e raised to x plus 1 dx by dy minus x e raised to x is equal to minus y e raised to y. Now guys, here if you'll check this term and if we put this term as v and if we find the derivative of that term, then it is exactly equal to this term. So this equation is matching with the form of equation reducible to linear form, which says that we can put f of y as v and its derivative will be f dash of y dy by dx, and we can put it as dv by dx. So by doing this substitution, we can reduce the given equation to linear form. So guys, here I'll say put x e raised to x equal to v. So let's find out the derivative. So here I'll apply the UV rule or product rule of derivative. So we will get x as it is, derivative of e raised to x is e raised to x, plus e raised to x as it is, derivative of x is 1, into dx, so dx by dy, because I'm differentiating with respect to y, because you can see here that we have dy in the denominator. It means y is a variable of differentiation. So always remember guys that here in this case we were putting f of y as v and here the variable of differentiation was x. Okay, so hence we differentiated both sides with respect to x, but in this case here in the denominator we have dy, so the variable of differentiation will be y. So I am differentiating with respect to y on both sides. So it is equal to dv upon dy. So if I take e raised to x common, then I'll get x plus 1 in bracket dx by dy. So it is matching with this term. So now guys, I can directly say that this term is equal to dv upon dy. So here we will get therefore dv upon dy minus x e raised to x is v, so v is equal to minus y e raised to y. And guys, now I can say that this equation got converted into linear differential equation form. So to solve this linear differential equation, we generally find integrating factor first and then we get the solution. So here I'll say therefore the integrating factor is given by e raised to integration of p into dy, because here y is the variable of differentiation. Now the question is, what is p and q? So if I compare this with the form of LD, then p is a coefficient of this v. So I can say that p is equal to -1 and q is equal to minus y e raised to y. So guys, here we will get e raised to integration of -1 dy, so which is equal to e raised to minus y. Now let's find out the solution. So here I'll say therefore its solution is given by. So to get the solution, let's observe the form. So in this form, y is the dependent variable, hence in the solution we get y into integrating factor. Now in our case, v is the dependent variable, so here I'll say v into integrating factor equal to, now in the integration we have q into integrating factor dx, because x is the variable of differentiation. So here I'll say q into integrating factor dy, because I have dy over here, plus c. So let's substitute the values. So v as it is, integrating factor is e raised to minus y, equal to integration of q is minus y e raised to y, into integrating factor is e raised to minus y dy plus c. So guys, by solving this, here we will get v e raised to minus y as it is, equal to, now here e raised to y and e raised to minus y will be cancelled. The integration of minus y will be minus y square by 2 plus c. Now guys, we got the answer in terms of v and y, but the original question was given in terms of x and y. So you can see here, so if the question is given in terms of x and y, then we must have solution in terms of x and y. So it means we have to do the resubstitution. So here in place of v, we'll resubstitute the values. So let's see here. So we had substituted x e raised to x as v. Now I'll resubstitute v as x e raised to x. So here I'll say therefore v is x e raised to x into e raised to minus y equal to minus y square by 2 plus c, or we can join these two terms, that is x e raised to x minus y equal to minus y square by 2 plus c. And guys, this is nothing but the solution of given differential equation. So here we have learned that how to reduce the given equation to linear differential equation form, and then how to get the solution. So I'm sure that you like this video and you want to learn more concepts of engineering mathematics. Then guys, do not forget to log into Ekeeda.com today itself, where you can get access to all videos at one time. Thank you very much.